What's up, everybody? Axe Wizard here, back with my game that I've been working on. Neurality 32, I think is what I called it. It's been over I think it's been over a month since my last update. I was really sick, and then work has been really draining lately. So usually, by the time it's time for me to close my work laptop, the last thing I want to do is stare at more code. And even though I'm excited to work on my game and tackle some of these problems, I've just been beating my head against the wall trying to figure out problems when it feels like I'm at 5% battery mentally. So, but hey, I got something to show. So let's go ahead and just fire up the game, and we'll see what we got here. So since we last left off, I added a planet. And I also added ship AI to like try to land on the planet. So it's not working as well as I would like, but it's working. So you see how they accelerate, they slow down. Some of the faster ships have a harder time, like decelerating. So, and that's what they're doing right now. So they'll sit there and they'll stop. Now, I've got other AI stuff to program as well, but that's what I'm working on. You may also notice that the UI is a bit more simplified. I decided to get rid of those really ugly metal circuitry side things, because those weren't looking that good. So I just ditched those. I feel like this is a lot cleaner to be able to see stuff. So I got rid of those. I added faction on the UI so I can see what faction the ship is, and I'm going to add a few more other details and stuff there too, but I think I just want to keep the UI very simple, because how it was before, and I still have to clean up those not components, nodes. Been working too much in React lately. So let's see, if we go to, I think it was UI. Yeah, UI, let's do right side panel. So if we go to the scene for right side panel, you can see on the left here, I've got a bunch of stuff hidden. So this was the metal texture and stuff that I was using before. You can see how ugly that was. And then I also changed the minimap sprite that was being used. So it's now just a lot cleaner, I think. It looks much better this way. So, and then I also tried this like 9-patch rectangle just sort of thing, and that looked okay, but there's still just lots of empty space, and it's blocking your view of what's around you. So I figured I would just keep it somewhat transparent, that way the player has more visibility. So I still have to get rid of this stuff, but I just left it there for now. But so I think it looks much better. Like if we were to just turn this back on to how it was, like we save this and then we also go back into our left side panel. Boom, boom. Oh, I messed up the margins on it too. That's right. I changed the margins to, I think it was this one. If we go to, yeah, so I had these set to like 20. There we go. So this is how it was. So if we save this and run it, you can see this looks really ugly. Like you just got this over here. Like this panel isn't even used until you click on something. And even then it's only showing up half of the screen. So why am I blocking the screen? I thought, like, you know, having a square view would be, you know, good because you can go in all directions, but I just can't help but feel it. It just feels cramped, and I always want to zoom out. And I find that I want to zoom out less if I can see more of the sides of what's around me. So if we just hide those, let me go set these back to 0 like I had them. 0. There we go. And then we hide these. Boom, texture, texture, don't need that. Save. Let's go back to right side panel. Boom, save. Let's run it again now. This looks so much cleaner. Like this looks way cleaner. It's simplified, and it'll be much easier to customize too. Like, you know, I've got like a, so if we move the planet like right over here, you can still see that you can see behind it, because it's somewhat transparent. So I think that is extremely helpful in case you're being attacked or something like that. So, that's a lag spike. I should probably fix that. Oh, I messed the wrong ship, man. This guy's got turrets that can always hit me, because I did last episode, I think I did like AI tracking, like weapon tracking, so this is dumb. This is a bad idea. Anyway, so let's go and talk about what I have done since last episode. So we already talked about simplifying the UI. I started a location class as well, so you notice that I have the planet on the screen now. I started putting some thought into what I wanted of a location, so I started a class for that, and I just popped some variables here. So I have location name, the location description, and then I was thinking about like what I would want to do. So, like, obviously, one of my big inspirations for this game is the Escape Velocity Nova game, and when you would land at a planet or a location or something, it would pop up this dialogue that would show like a picture of what it's supposed to be like. And I figured that format would work really well for me, since almost all my art is AI generated for this game, because this game is going to be the story. Once I get to that, is going to be heavily focused on just the dystopian AI future that awaits us. And that's why it's called Neurality 3092, because it's going to be in the future. And then I figured, like, you know, neural network AI stuff, like it's going to be the new reality, the Neurality. So, but there was already like some AI group called Neurality, so I just named it like Neurality 3092 because it sounded cool, kind of like Cyberpunk 2077. I thought about calling it like Cyberjunk 3077, but then I don't want to get copyright, so that's fun. So that's what I was thinking for locations. So this is bare bones stuff, and then I don't really have anything planned with it yet as far as like functionality for it. It's mostly just storing stuff, and then I can make scenes kind of like how I did for my ships. I could just have a bunch of planets, and then locations, because they might be a planet, might be some distant moon, might be like a wrecked space station. Who knows? Could be some alien biomass in a system. You don't know what it is. So I'll just make a bunch of locations, and then you can land at those locations if you get close enough. So that's what I was working with the AI, is so that they like slow down and it looks like they're kind of stopping. I had an idea that was maybe like, oh, maybe I could like shrink the ships down so that it looks like they're like landing on the planet or whatever, but I don't know if I want to do that. I might try it out just to see if it's fun, but I've been fighting for several days trying to get this deceleration thing to work. So let's jump into that. Let's talk about what I did with the ship. So, holy cow, there's so much code in this ship now. So let's minimize a bunch of the stuff that we're not using. So let's start with my AI control function here. So let's minimize all this. I'm at 788 lines of code for my ship class. Starting to get a bit ridiculous. So for my AI control function, I'm doing what I did before. I'm resetting my inputs, and then I'm basically running these AI state functions. So I put a comment here because it had been a while since I looked at my code when I was sick for like 2 or 3 weeks, and I came back and I was like, why am I not putting this in like a switch statement, or I think it's a match statement in Godot. And I realized that it was a deliberate decision, so I commented that. So basically my thought process is that the function itself is responsible for checking to see if it should be running code. That way, say for example, if we're running AI state idle, that's my default like AI to run, and it sort of determines, it just goes through and like, hey, do we have a target? Should we be pursuing it? Should we be attacking it? If we're not under immediate combat, should we try to like go to a different location? Should we just fly around somewhere? So the AI is sort of the AI state idle is sort of just the base decision maker, and then once it makes a decision, then it will set the appropriate state. So I was thinking like, oh, it'd be super optimized to be able to make that decision and also like start executing that decision within the same process event. Realistically, it's probably not going to have that much of an impact. Like, I don't think it would be noticeable at all, because it's, you know, if your game is running at like 60 frames per second, it would take 1 frame. It would 1/60th of a second is all that difference is. Probably not that big a deal, but I just did it for fun. But I commented what I was thinking. That way I can come back, and if I decide that it's just a superfluous thing I don't need, I can just tweak it and throw these back in a match statement. But I figured this was clean. So AI state idle, I added this AI state move function because before this was to do. So move is different than intercept. Intercept is when we're trying to intercept a enemy target, such as another ship. And then AI state move is just like, hey, we have a destination, go to it. So I started on that. So let's look at what we got for AI state move. So again, we're checking if we're even supposed to be running the code. So we're just checking if our state is actually state move. If it's not, then we're just returning early, do nothing. Then we're assuring that our inputs are reset here, because I was having some problems with that. So I just made sure that I always reset my input. That way, you know, like decelerate or accelerate isn't stuck. And I might not even need this anymore now that I fixed it, but I've got it there. It doesn't seem to be hard, or doesn't seem to be hurting. So what we're checking is currently my move is only valid for a target location. So it's this location type that I made. So in this case, the planet is the only location that we have. But if there's no target location, then we want to return. So where do we get target location from? Well, let's go back to state idle. So we have all this stuff here where, you know, we're checking if we have a target. If we don't have a target, we're checking to see if any targets exist. And yeah, we're just double checking if we have a target. If we do, then we're going to handle that. If we don't have a target still, it means that we don't have any enemies on screen. We don't need to be worried about it. So then I just have like this logic block that's like, okay, we don't have a target. Do any locations exist? So I'm using another group called locations. So when my planet gets created, it's being added to the group locations, and it's just simply getting an array of all the entries in that group, and we're just verifying, hey, did we get any results back? If we do, we have at least one location, but just to be sure, for now, I just pick a random one. So if I go and on my main scene, if I go and I add in another location, it'll pick one of the two. It'll just pick one of the random ones. So that's what I've got right now. It's probably going to be changed just proof of concept mode. Once we actually set our target location, then we set our state to move, and that's what we're doing there. So let's go back and minimize this bad boy. Go back to move. So we're just saying, hey, is our instance still valid? Because I don't know. Maybe we're gonna blow up a planet or something. I don't know. So we're checking that. All right. So next we got, are we within a minimum distance to our destination? Now, what I'm doing here is I was having a problem to where, because of how floating point numbers work, you'll never be like right on it. So my ships kept like turning around and then trying to go back and then turning around and trying to go back again. And so I just, let's see, I'm going to move these up a little bit. So cut these out. Declare some variables we'll use throughout the logic. There we go. So what I do is I have this distance to target, which is just basically taking my global position, using the distance to method to my target location global position. So we're also making sure that you know, we already talked about making sure that our target location is valid. So we're doing distance to target. If it's like within 25 like pixels or whatever, we're close enough. Just doesn't have to be right on the money. Just stop. So then what we're doing here is we're just telling it, just decelerate. Don't worry about it. Just get close enough. Just decelerate. And then we're checking, hey, does our magnitude actually equal 0? And then if it does, then we go back to idle. So let's talk about this stepify function here. This came up because I've spent days fighting with this code. This is great. When I was doing my turning logic, which is like, I'm using the same logic in like my intercept code, and also I think I'm using it in my weapon turret code to determine which way to like rotate. But basically we're doing get angle 2, so which is from our position, our global position, to our target location global position. So we're getting that angle, and then what we're doing is we're just converting that from, because that function gives us radians, but we want to work with degrees. So we just convert that radian to degree function, and that gives us the angle. So, you know, say if my ship is like right here, and you know, my the get angle 2 also takes into account your angle too. So if my ship's right here and it's facing this way, and the other enemy ship is like right up here, it knows that it has to turn this way, not like the other way. So that's what this logic is doing here. Now what the stepify does is it says, I put a comment right here because I'm super smart. Look at me go. Let me zoom out just a tad. There we go. So here we use stepify to make sure we don't have a value like 0.0000009. Because what was happening is that, now we're doing this because what I wanted to have happen was that I want the ship to like come to a stop, and I want it to rotate and face the direction that it needs to go, and then start to accelerate. That way we don't have to like compensate for like, you know, oh, you got to like also rotate a certain way to get in so you can land perfect or whatever. Just stop, face the direction, and then go. So that's what we're doing there. So what was happening is that I had a ship that was stopping, and then it was turning, and then it just wouldn't do anything else. And I couldn't figure out why, and so I started like printing stuff out to the output log here, and it found out that the angle was like it was this like 0.00009 because of how floats work. So what I'm doing is I'm just like capping it, like I only want you to go to like the third decimal place or like whatever. So that's what we're doing there. We're just capping that angle so it's within that range. So in this case, 0.00009 would just turn into 0.000 or just 0. Actual 0, which is what we wanted to actually check. So after I figured that out, so if our angle does not equal 0, that means that we're not facing our target. So just slow down. So we have our decelerate action set to true, accelerate to false. And then we're determining which direction we need to rotate. If it's a positive direction, we got to rotate right. If it is a negative, we need to rotate left. And then here is where we're determining if we need to turn our full speed or just turn a little bit to actually get on point. So this is what's happening here. So like if our turn speed times delta change in time is greater than our angle, that means that we're going to overshoot. So we're just we're just setting our rotation to just have that remainder. So that little function there, that was giving us that weird 0 point whatever because of how floating point numbers work. So that's what that stepify was for. So that was really fun to figure out. And so we've already done turning code. I'm not going to go over that again. I guess I already did, but whatever. So once we figure out turning, if our angle does equal 0, then that means that we are facing our target and we can move. So here I'm just setting accelerate to be true and decelerate to false. Now, I also put a comment here that says next few lines will change this if necessary. I just want it to accelerate if necessary, because the calculation to figure out, like, you know, how long it's going to take for you to, like, when do you need to start decelerating, you have to do division. And if you're stopped, you can't divide by 0 because you're going to crash the game. So what I'm doing here is I'm just setting my action accelerate to be true. And then if my, so say if my ship is, like, you know, at a stop, say it was already perfectly facing the thing, or say it came to a stop and then rotated, we haven't moved yet. So if our magnitude, which is what we declared up here towards the top, it's just our length of our vector. Remember, vector is just a arrow that represents direction and magnitude. So the direction of where we're going, and then the magnitude is, you know, how far. So velocity is my variable that tracks how much I'm going to travel in a given second. So that is that's what the magnitude is. I just declared it here, that way I'm not doing velocity.length like 60,000 times. So I just declared it up here. That way I can just reference magnitude, because that's what I'm trying to do. So if our magnitude is 0, we're not moving, our speed is 0. Well, we can't divide by 0, so just return for now. So what's going to happen is that this is action accelerate is going to be true, and then the ship is going to move a little bit, and then the next time this code runs, this is not going to be true, and then we can actually move on to let's determine how long it would take to stop. So this is where I spent a lot of time trying to figure out how to determine, like, okay, how not like how long, but like what's the if I start like how long would it take me to stop, like in terms of distance, like how far will I go, like how what distance will I travel if I try to stop right now. And so I looked on like Google, and like there's like 30 answers, man, and like most of them are like calculus and like physics equations, and I'm just like, oh, I don't. So I was trying a bunch of those, and just nothing was working, and it was all convoluted. So I just started playing around, and I found this that kind of works, and I don't quite know why it works, but. So magnitude divided by my deceleration speed, also divided by delta. So I was looking at the top of my code here. So if we look at, oh, where is it? So my deceleration speed, I have 0.5. I put a comment like to do. I don't even know what unit of measurement this is supposed to be in. So already there, I was at a disadvantage, because I had no idea, like, is this like in pixels? I don't know. So I started looking at how I was using this, because keep in mind, movement was one of the first things I did when I ported this game to Godot, and it was a learning experience. So I was like, okay, well, do I have to change my movement? So if we go back down to my process event, or my process function here, let's see. So I'm declaring a just a fresh empty vector 2, just a zeroed out vector, and I'm calling this motion. And I am determining so acceleration speed and delta, and then if I want to decelerate, this is the important part here. So we're doing we're decreasing the magnitude of our vector. So our velocity is like what our ship is actually moving at. Motion was the change that we were going to apply to that velocity. So here we just have, you know, velocity length, and then we're just subtracting it, deck speed multiplied by delta. So that's what we're doing to slow down. So I was like, okay, well, if we're doing all these multiplication stuff here, why don't we just do division down here? So here you can see like how long it would take us to stop. I figured, okay, well, let's just take the magnitude, which is our velocity. It's how fast we're currently traveling. If we divide that by our deceleration speed, and then also divide it by delta, because when we apply it, we're multiplying it by delta. This should give us the actual distance, and I don't know if it does or not. So let's take a look at like some math here. If we pop open a calculator, right? So let's go look at our thing here. So let's say max speed here, right? This is our maximum speed that we can travel. I have a comment here that says 240. So let's see, how am I applying max speed? Let me go back down here. Okay, if velocity length is greater than max speed multiplied by delta. So remember, delta is the change in time. So it makes it so you're not dependent upon frames. So if my game is running at 60 FPS or running at 120 FPS, it should be the same. So if we take a single second and we divide it by 60, that gives us like 0.016. Yeah, 0.016, yeah. So basically this is like, this would be, in theory, our delta. If it was like, if it was 120 frames per second, it might be like 0.008, right? So maximum speed. So say for example, if we're traveling at max speed, just for funsies, say our velocity is 240, right? That's what we got. So if we take our velocity, let's go down back to my logic here. So say our magnitude is 240, and we divide that by our deceleration or our deceleration speed, which is 0.5. So divide 0.5, it's 480. It basically doubles it, right? And then we're dividing it by delta. So if we divide 0.016, this gives us like 30,000. So in theory, it would take us about 30,000 like pixels or whatever to actually slow down based on our deceleration speed. Now the calculation is not perfect. So yeah, so distance to stop. So say for example, if we're not traveling at max speed, say if we're only going, I don't know, like, so our max speed is 240. What if we're only going like a quarter speed? So we're only going 60, like per second. Then we would just do, you know, we would take that, divide it by our deceleration speed, which is 120, and then we would divide it by our delta. So it'd be about 75. So that I think that, yeah, I don't know, but it seems to like work. So like you can see they're accelerating and then they're slowing down, and they're usually like right on the money. But the ones that are going like the bigger ships, like you can see they kind of overshoot it. So it's not perfect, but it gets them close enough. So I might tweak it. I might leave it alone. I'm probably gonna work on it some more, but I got something that roughly works without having to do like insane calculus equations. I don't even want to go into detail about all the stuff I tried. Like at one point I was doing I'm not gonna talk about it. I tried a lot of different things. Some solutions not that good. This is a decent solution. It's not that resource intensive, so we're good to go. So once we calculate what our distance to stop is, then we're just say, hey, if we're within that distance, slow down. So that distance to target, we declared that earlier up here, distance to target. So if we're within that distance, slow down. So if our distance to target is less than our distance to stop, then we need to start decelerating, slow down. If not, keep on trucking, just keep accelerating. So that's what I've got so far, and it seems to be working, so I'm going to run with it. I'd be curious. Let's actually throw in a few more ships. Let's do, I don't know, test ships 50. and then run it. See how this works. So you can see we got a bunch of ships now just moving towards this this one single location. And for the most part, they're all like right on the money. Like they're all there, you know? So I think it's close enough. And so I'll work on adding like some more behavior. So maybe they'll stay here for a bit and then they'll start heading out. And then once they get to a certain distance away from the planet, they can hyperdrive out of here. And then I might have ships come in and stuff like that, just like EV Nova did. But, you know, I don't want to reinvent the wheel if I don't have to. I liked that, how that made the world feel. So I might just take that, and then maybe I might add my own tweaks to it. But, I mean, for the most part, I mean, you can see that it's working. So let's piss off this big ship just for fun. Oh god, I keep forgetting I did the turret targeting, so it's like super dangerous to be a tiny ship. Get wrecked. Oh boy. Alright. But anyway, that's what I've been able to do so far. But now that I've got that, I still have some things on my to-do list. Like I wanted to finish the rest of the right panel UI, so there's a few things I wanted to add on there. I also wanted to finish the mini-map. I'm kind of happy with how the mini-map looks now. I was gonna generate some more markers because they weren't that noticeable. I think they're okay now, but they can definitely use some work still. And I also wanted to allow zoom on the mini-map as well. So I was gonna figure out how to do that. And then I also wanted to make it so you can't initiate combat with someone of your own faction. So if I'm on faction bros, and I target a ship who is also faction bros, and I shoot that ship, I shouldn't be able to hit it, and like we shouldn't be able to beef it out, because that would just suck. So I still have to fix that. I was going to work on my UI theme some more. I did that quite a bit, just tweaking what I wanted to do for UI. I think I'm just going to go with a super simple one, because all the grandiose ideas I had, to be honest, just looked terrible. So scrapping those. I was going to create an actual theme, like a styling theme for the title screen. I should specify styling theme. There you go, style theme. Because I already created a music theme, so cool. And then I was going to add planets and space stations. I kind of got that process started, but I want to add a few different ones. And then a big thing was I was going to refactor a lot of my code to use signals, because there's a lot of code I have that's just constantly checking for something when I could just use a signal and then just do a certain action whenever I receive a signal. I think that might be more beneficial. It's certainly how Godot wants you to do things, so I have to do that. But that's what I've got going on so far. I just wanted to give a little update. I haven't stopped working on this. I just took a bit of a break from it because, again, I was sick, and then work has just been absolutely a soul-sucking experience lately. Like, I just have zero creativity by the time I'm done. So it's been a bit, but I'm starting to get back into it. And I've also been working on starting to plan out a video series to help people who want to get into programming. And I'm trying to make it like a language agnostic thing. Like whatever language you're going to learn, these concepts will probably help you. So the things I'm going to tackle are just like, what are variables, like how you would use variables, common data types, so things that are shared with all the different languages, and also how to use those, and then just like basic logic stuff like if statements and things like that, stuff that just about every language has. So I wanted to get in those and sort of come at it from a perspective of if I could go back in time and like tell my earlier self, like, hey, learn this stuff, it's going to help you. I want to come at it from that perspective. I think that would be helpful for people. So I'm working on that, and yeah, anyway, thank you so much for watching. I appreciate it, and I'll see you in the next episode.